Welcome to our first official lesson in the Polynomials unit. So we're going to look at 3.1 on page 5, factoring polynomial expressions. So we're going to do a few examples today, or quite a few, and then you're going to be able to try some on your own within this lesson too. So let's just start off by factoring this first one. The first thing you want to do is see if there's any common terms between each of them, or common numbers between each of them. So the first one has a common number of 2 in each term because I can factor out the 2. If I do that, I'm left with x squared minus x minus 6. So again, in order to get this inner part, you would divide each term by 2 because we're trying to factor out the 2. Now, I want to factor this inside part here. Usually, what I would do is look at the factors of 6. So I know 6 has factors of 2 and 3 because 2 times 3 is 6. Now I'm going to try to create that middle number, and this is a -1 with using 2 and 3. I can create a -1 if I had a -3 and a +2. And then that's it for that polynomial. We're done factoring that. Now this next one, there is a trick to it. We can factor out 0.1, and if we do that, we can get rid of our decimal places. So what I want to do is factor 0.1, and if I do that, that means I also multiply each term by 10. Okay, so now I'm left with 10x squared because I'm multiplying x squared by 10. Then I have 4x because if I multiply 1.4 by 10, I'm going to get 14. Then lastly, multiplying 1.2, I get 12. Then multiply it by 10. And then now we're going to factor this inner part here, which looks very similar to a. So I'm going to factor out a 2 because a 2 is in common between 10, 14, and 12. If I do that, I'm left with 5x squared plus 7x minus 6. And again, to get this inner part here, I would divide 10x squared by 2, 14x by 2, and -12 by 2. Now I'm going to take a look at that portion and try to factor that. Now, depending on your teacher from Pre-Cal 10, there's different methods on factoring something like this when you have a number in front of the x squared. I'm going to show you again my box method. So I'm going to choose 5 and 1 at the top of my box and then factors of 6 on the bottom part of my box. So it can be 3 and 2 because that creates 6. Now the next step in the box method is to multiply, cross multiply the following numbers in the box. I'm going to do 5 times 2, which is 10, and 1 times 3, which is 3. And hopefully my pair here can create a 7 somehow. And it can if I had a +10 and a -3. So these signs are going to reflect just above here. And these are the coefficients that will go inside my bracket. And remember the first number at the top, this has an x with it. So this is 5x minus 3 and then x plus 2. And then to finish this off, I can multiply the 2 with the 0.1, which is 0.2, and the rest remains. For C, we start off with a fraction. So same sort of concept. We kind of want to get rid of the fraction when we're factoring, and we can do that by factoring out a quarter. But when we do that, we're going to multiply each term by 4 to get whatever on the inside after we factor out a quarter. So multiplying that first term by 4, the 4 and the quarter is going to cancel out, so you get x squared. 4 times negative x is negative 4x. 4 times negative 3 is negative 12. And then we're just going to factor our trinomial here. So there's no number in the front of x squared. I'm not going to use the box method, just a simple method. So our factors of 12 can either be 6 and 2 and 3 and 4, but I need to create a negative 4. So how is that going to work if I have 4 and 3? Well, we can't, so we're going to pick 6 and 2. So 6 times 2 is 12, and I can create a negative 4 if I had a negative 6 and a positive 2. And that is fully factored. Why don't you try the next one, because it's very similar to C, and then when you're ready, press play. All right, so here's the next one for the try it yourself. You want to factor out the half, just like how you did in example C, and you're going to multiply each term by 2. Once you've done that, you can factor out the x squared minus 2x minus 8, and factors of 8 are 4 and 2, which can create that middle term negative 2 if you have a negative 4 and a positive 2. So in this next example, it looks kind of crazy, but if you simplify it, it's actually quite simple. Instead of having this x plus 2 in there, let's replace it with a y. So I'm going to say let y be x plus 2. So what we're going to have now is 12y squared plus 24y plus 9. Now it doesn't look as scary. Our next step is to factor out a number in common between 12, 24, and 9, and that's going to be 3. So to get this stuff on the inside of this bracket, you're going to divide each term by 3. So 12y squared divided by 3 is 4y squared. 24y divided by 3 is 8y. 9 divided by 3 is 3. So the first thing we did here is factor out 3. Okay, now we're going to factor the inside part, which is 4y squared plus 8y plus 3. And we can do that again using the box method. So for factors of 4, we know 2 and 2 can multiply to get 4, and then factors of 3, there's only one set, and that's 1 and 3. So I'm going to cross multiply to get the numbers down here. So 2 times 3 is 6. 2 times 1 is 2. And then I want to create a positive 8 with these two numbers down here. And I can if they were both positive. And this sign is just going to reflect up. This is what's going to go in your brackets. So the top number has a variable with it. So that's y, 2y plus 1, 2y plus 3. Now we're almost done. It looks factored, but we also replaced x plus 2 with y, so we need to plug that back in. And we can't say we're done yet either because we have to simplify. So here we put the x plus 2 back in. And now we want to simplify. So that's 2x plus 4 because I'm going to distribute this bracket. (2x plus 4 plus 3), and then lastly, I'm going to simplify everything inside the bracket. So that's 2x plus 5, 2x plus 7, and now we are done. So go ahead and try the next one. It's very, very similar. Okay, so for this try it yourself, My first step was just to factor the 3, but if you change your 3x minus 4 to another variable first, that is fine as well. So I just factored the 3 out of each term. So I did 6 divided by 3, which is 2, negative 21 divided by 3, which is negative 7, and 15 divided by 3, which is positive 5. Then afterwards, I let z be 3x minus 4 and replaced each of the 3x minus 4 with z. Okay, and then afterwards, I factored out the 2z squared minus 7z plus 5. And I use a box method for that. And you should get 2z minus 5 times z minus 1. Then afterwards, I can plug in the 3x minus 4 again. And then I simplified each set of brackets by expanding. And then after you expand, you're going to simplify each set of brackets, and then you'll be done. Okay. And this next example, we're dealing with difference of squares. So in your difference of squares, it's fairly standard. You usually have a minus in one of the brackets and a plus in the other set of brackets. And to figure out the first term, they're going to be the same in each bracket, and it's always going to be the square root of 9x squared. So the square root of 9x squared is 3x, because I know 3x times 3x gives us 9x squared. Now we're going to have the same thing for the second term. We're going to square root this, and whatever we get is going to be in the same place for each. So that's going to end up there. So the square root of 0.64, well, we know the square root of 64 is 8. And we definitely know that the square root of y squared is y. But we have to count for this 0.64, so this is just going to be 0.8. And then that's it. Same sort of thing for the next one. We know one of them has a minus in the bracket and a plus in the bracket. So that's for difference of squares. The middle term has to cancel out. So we're going to do the same thing, square root each of the terms, and that's what's going to end up in our brackets. So for the very left side, the square root of x squared is x, and the square root of 9 is 3. So that's going to show up in the same place in the other bracket. The square root of 4 is 2. The square root of 25 is 5, and that shows up in the other bracket as well. So you know, once you use this method, whenever a difference of squares, there's always going to be a minus. So like an x squared minus a y squared, or a number squared, something like that. If there's a plus instead, then we can't use difference of squares. It has to be a minus. Okay, we're just going to do another one. And it's very similar that it looks kind of messy right now, like how am I going to do this? But you can simplify it first. So we can call this A, and we can call this B. So A can be 2x minus 1. B can be y plus 4. So if that's the case, then we're just left with a squared minus b squared, which looks fairly simple now. And then we can do the difference of squares for that. So this is going to be a plus b, a minus b. Remember, we need a plus and minus in each bracket, and then we'll just take the square root of a and the square root of b. Okay, now I can just plug in the 2x minus 1 and the y plus 4 back in. So a was 2x minus 1, b was y plus 4. And I'll do that again for the other set, 2x minus 1, and this time is minus y plus 4. And then we're going to simplify. So we're just going to open up all the brackets and add up our terms together. The 2x doesn't have a buddy to go with it. It's just standalone because there's nothing else that's similar. There's no like terms. Same with the y, but we can do -1 plus 4, which is 3. So that's one bracket. Here we had to distribute this negative to each term. So that's 2x minus 1 and then minus y minus 4. So that negative goes into the y and the negative goes into the 4. So we have 2x minus y, -1 minus 4 is -5. Then we're done there. Just do one more example with you and then you can try the very last one on your own. So again, I'm going to let this be a and let this guy be b. So a can be 2t plus 1, b can be s minus 2. And then we'll replace that and then factor it after. So again, we can tell this is different as squares. We can easily take the square root of each and get whole numbers in a solid a and b, and we have a minus in between them. So we know that one has to have a plus and the other one needs to have a minus. Taking the square root of 9a squared, 9a squared, that is 3a as the first term in each bracket, and then taking the square root of 4b squared, square root of 4 is 2, square root of b squared is b. Okay, and then now we're going to plug our 2t plus 1 and s minus 2 back in. I'm just changing it to square brackets because it's just easier to organize the information. And it's very important that you put your brackets in. Otherwise, you can make the wrong calculations if you omit the brackets. Okay. Now, again, it looks like a mess. So we do have to simplify it. We're going to multiply this 3 with the 2t and with the 1. And this 2 with the s, and that 2 with the -2, and so on. So we're going to have 6t, that's 3 times 2t is 6t, and then 3 times 1 is 3. We have 2 times s, which is 2s, and then 2 times -2 is -4. Then another set of brackets, we have 3 times 2t, which is 6t, and then 3 times 1, which is 3. We're going to multiply by -2 to s and -2. So -2 times s is -2s, and -2 times -2 is +4. And now we're going to simplify each bracket. So 6t and 2s, they don't have any like terms, so they're just going to stand alone. And then 3 minus 4 is -1. 6t and -2s, again, is standalone. There's no like terms, but we can do 3 plus 4, which is 7. And then we are done factoring d. So why don't you try the next one on your own. So set a and b for x plus 2 and 2y minus 3, and then factor out the 2 first from 32 and 18, and then continue on. Okay, so when you're ready, here's the solution. So the first thing you do is factor out the 2 out of 32 and 18. So then you're left with 16 and 9. And these are perfect squares, which is what we want. Then I replace the x plus 2 with a and the 2y minus 3 with b. And then I want to factor the 16a squared minus 9b squared. So the square root of 16 was 4. The square root of a squared is a. That's how I got this first term, and it will occur in both brackets. Then the square root of 9b squared is 3b, and again, 3b will occur in both brackets, and you should have a plus in one and a negative in the other bracket. Then afterwards, I plugged in x plus 2 and 2y minus 3 back in. Then I simplified Remember, when you simplify, you do need to distribute your brackets. So 4 times x, 4 times 2, 3 times 2y, 3 times negative 3, 4 times x, 4 times 2, negative 3 times 2y, negative 3 times negative 3, and so on. So once I did that, this is what I got. And then I simplified each bracket. So I added the 8 and the negative 9 and the 8 and the positive 9 there. And that is your final answer. So you can find the homework on page 11. So you have to go through a bit more because you're on page 7 right now. So just go to page 11.